Good evening everyone, myself Aditya, and now I am doing the topic of MINIATC of the Automata Theory and Computation course. So going to the introduction. Automata Theory and Computation is a fundamental area in computer science that provides the mathematical foundation for the designing programmers, languages, compilers and interpreters. Concepts like DFA, deterministic finite automata, and context-free grammar are essential for performing lexical and syntax analysis. During the compilation process, this assignment demonstrates this concept through a practical implementation and custom language called the MINIATC. So mainly the objectives of this assignment are to understand the practical application of automata theory in software design, to design a DFA for accurate token recognition, to implement lexical analysis and syntax analysis using CFG, to validate programs for both lexical and syntactical corrections while generating a registry. So moving to the level 1 identifier recognition. So in this level, we mainly focus on the whether a given string is a valid identifier or not. So the rules are like must start with an alphabet, contains an alphabet and digits, cannot start with digits, cannot contain special characters like at, dollar or any other symbols. So this is a DFA which contains two states, Q0 as starting and Q1 as the final state. So the variables here are letters or the digits. So coming to the valid and invalid cases, level 1 identifier recognition. So taking a string like X, so the transition between Q0 to Q1, X will be present as its letter, which is an valid identifier. Next, taking a total 1, so T will be consumed in Q0 to Q1. Then a loop from O, T, A, L will be comes under a loop of Q1, and lastly a digit 1 will be of the Q1 loop. Next, take an example of MINIATC 2026. So in this, the first the letters mini and ATC, these are the letters which goes from Q1 to Q0 to Q1 and then Q1 loop, and then last 2026 will repeat in the digit loop, and it is also a valid identifier. Next, coming to the invalid cases like 1x. 1x it's an invalid cases because Q0 to Q1 starts with a letter, but 1 is a digit which is not been possible in this TFA, therefore it is invalid. So another string is like AB minus C. So AB will be accepted, then minus present. So minus is not there in a minus symbol is not been consumed in this TFA, therefore it's invalid. Next comes an example of $B, which is an invalid because dollar is a special character and the special characters are not allowed in this TFA. So running the program of the level 1. So level 1 MINIATC level 1 identifier checker. So the identifier I will give is MINIATC 2026. As it's an valid identifier, it should give the valid output. Yes, it's a valid identifier. Now let's check for invalid cases like $8 it's an invalid because it is a special character. So moving to the next level 2, mini lexical analyzers. The second level focuses on tokenizing a MINIATC program. A lexical analyzer level 2 mini lexical analyzer. The second level mainly focuses on tokenizing a MINIATC program. A lexical analyzer scans the input program and divides it into mini full tokens. The lexical analyzer performs the following steps like reads the input program, scans character by character, matches the patterns, classifies tokens, reports invalid tokens if found. Tokens identify like keywords, begin int, identifiers, numbers and operators. Operator like plus is equal to, and delimiters like semicolon and brackets. So this is a DFA of Q0 to Q1. There will be a consumption of letters. Q0 to Q3 there will be consumption of digits. Q0 to Q5 there will be consumption of operators, and Q0 to Q7 there will be consumption of delimiters. So taking the examples like int consists of 3 letters. The transition between them is Q0 to Q1 and the loop of Q1. Therefore it is acceptable. Then coming to the x equal to 10. So has its token. So basically first x will be accepted, then is equal to be accepted because is equal to comes under the operators, and in q of I it is present. Then comes 10, 1 0 1 0 will be accepted in the digit section, therefore it's all the tokens will be accepted. Next, coming to the data 1 equal to x plus 25 star y by 5. In this case, x will be accepted as its digit plus 25, addition plus 25. 25 is a digit, it will be accepted in this digit section, digit q3 state. Next, other delimiters like bracket or star, and also this semicolon will be accepted in the q7 delimiters, therefore all tokens will be accepted. So coming to the invalid section, like at which is a special character, it will be not accepted because there is no consumption of any special characters. And coming to the x, $y, x and y will be accepted, but dollar will not be accepted because it's also a special character. Another input is like a 12a hash b. Hash is also not a special character, therefore it will not be accepted. So running level 2. If I run level 2, there will be lexical analyzer. So like let's give an input equal to x equal to 10. Tokens found, identifier is x, operators equal to, numbers are 1 0, delimiters are semicolon. Now for invalid case like x at y semicolon, it's an invalid token because at is a special character. Next, level 3, lexical analyzer plus freezer. The third level combines lexical analysis and syntax analysis. After tokenization, the freezer checks whether the token sequence follows the grammar rules of the MINIATC. Phrasing process: tokenize the input program, starting phrases from program rules, matches tokens according to the grammar rules, detects syntax error, generate phrase tree according to the valid program. So this is the grammar which is used in here. It's like a protection. Declare statement, the program statement. So this is DFA of Q0, Q1 and QF. QF is a final state, Q1 is a start state. So the grammar is simplifiedly like program being statement end. So starting should be of being or push program. Expand non-terminals using production, mass terminals. So valid cases are like is being end. Being end is a valid cases because the transition is from Q0 to Q1, then at Q5 it's also valid cases. And the examples like int x, semicolon, x equal to 10 and end, it's a valid cases. Then coming to the non-valid cases of being end, it is a non-valid cases because the extra symbol is d after the end. So being end, basically it will be accepted, but at last there will be d, which will not be accepted at our correct condition. So when we just run this code, it gives us the this phrase tree with the valid identifiers. We check for being end, valid program, phrasing successful, starting program, begin, end. Again checking for an inner string being end. So it's an inner because of expected equal to, but got UF token, not the token is not been found. So conclusion: the project successfully illustrated the application of automata theory in programming language processing by advancing through identifier recognition, tokenization, and recursive decision phrasing. The assignment provides a clear practical understanding on of how compilers utilize DFA and CFG to process a source code. Thank you.